All right, guys, today we're talking about straight line motion. And again, we've seen this, we've done this multiple times. Now that we are using integrals, we're just using this in a different way. So a couple of things to remember. There is a difference between displacement and distance, okay? If it's asking for displacement, it's asking for the difference from where you start and where you ended. So on this graph right here, this picture, my displacement would just be this distance right here from where I started and where I stopped. That distance right there. The distance that I traveled all the way to this end point, and then I traveled almost all the way back. So I would be adding those two distances together if I was looking for the distance that I traveled. So that means when we're doing the math with this, you've got to be really careful reading the questions and making sure you understand if it wants displacement or distance. Now, using integrals to find this, all you have to do, if I'm given a particle moving along a straight line, if I have the velocity and I'm going from A to B, my displacement, so the difference from where I started and where I stopped, is just the integral from A to B of my derivative, of my VT dt. The distance, remember we did this a little bit in the last unit, the distance, I've got to take the absolute value of my function when I do the integral. That's the only difference. Displacement, I don't use the absolute value. Distance, I do use the absolute value, okay? And these are two things you're going to want to memorize. This is going to take a lot of these problems and make them easier when you know what the derivative is, because all you have to do is find the integral. You just have to be sure that you use the right formula, but make sure that you memorize these two. Now, just a reminder, again, this is all stuff that we've seen multiple times this year. In fact, I think this is our third or fourth time. But there are also things that you need to remember for the AP test. So first of all, S of t is our original function. That gives us our position function. S prime of t, if I take the derivative of position, I get velocity. And S double prime of t, or the derivative of my velocity, gives me A of t, which is my acceleration function. Okay, I think you guys have all done a pretty good job getting these ones down and remembered. I feel like we need to say that we reminded you, all right? If nothing else, it's been a long Christmas break. So also remember that speed is the absolute value of velocity, okay? So if the velocity and the acceleration, if they're the same sign, then our speed is increasing. If the velocity and acceleration are opposite signs, then our speed is decreasing. What else do we need to review? The sign of the velocity tells you the direction that you're going. If your velocity is positive, you're going to the right or up. If your velocity is negative, you're going to the left or down. If your velocity is 0, which we use all the time, remember that's when the object is not moving, it's stopped. And then with acceleration, remember it's the change of our velocity over time. So the sign of our acceleration tells you the direction that we're accelerating. It does not tell you the direction that we're moving. It tells you the direction that you're accelerating. So if our acceleration function, when we're greater than 0, if it's positive, that means we're accelerating to the right or we are accelerating up. If our acceleration is negative, we're accelerating down or to the left. And again, if it's 0, then we're not accelerating at all. All right? Okay, so a couple of problems here. Let's work through them. Given the velocity of a particle in feet per second, find the displacement and the distance traveled at the given time interval. So right here you have two different functions, or two different graphs of the function. My function's right here, velocity equals e to the t plus 1 minus e. So it's not a very pretty function, but it is what it is. This is what the graphs look like. Okay, now this first one is just my e to the t plus 1 minus e. That's this top graph. So if I was looking for displacement, then this is kind of the graph that I'm using, right? If I'm looking for my displacement, I'm just using the original function. But if I'm looking for distance, remember I take the absolute value of e to the t plus 1 minus e, which means this part of the graph that's under the x-axis is going to flip and be above the x-axis. So that's what the graph, if I was looking for the distance, then the graph is going to look like this one on the bottom. So the top is just my original function. The bottom is what it looks like when you take the absolute value. You just take what's underneath the x-axis and mirror it to be above the x-axis, all right? So I know my function. If I want to find displacement first, then displacement, I take the integral, and I'm going from -2 to +2, and I just take the integral of my function. So e to the t plus 1 minus e dt. Okay, now with these problems, what we're going to be doing today, we're not, a lot of these, well, in fact, most of it, we're going to be working with the calculator. The functions that we're given aren't very fun functions to take derivatives of. This one wouldn't be too bad, but in my calculator, I'm just going to go math, and I'm going to go to my integral, so 9, and I'm going to put -2, and I want to go to 2. And we're going e raised to the, now in the problem it says t plus 1. My calculator doesn't know the difference between letters. So if I'm being precise, if I'm following the problem exactly, then I would put a t. I would use alpha t right here. I don't care about being precise because my calculator doesn't know the difference. So even though it says a t in the problem, I'm going to use an x plus 1, and then I'm going to minus another e. And then I'm going to make sure that my dx matches my x up there. Okay, as long as those are the same, then my function's going to come out okay. So when I hit enter, I get that my displacement is 8.84453. 8.84453. So we're going to say the displacement is 8.84453. All right. Now, if I'm taking, well, it's approximately, right? Because we're rounding a little bit. And I am getting lazy. I better use my units in this problem. Displacement is distance, and it tells me my velocity is feet per second. So my displacement is going to be in feet. Okay. Now, to find the distance traveled, the total distance traveled, I'm going to do the same thing, but instead of just e to the t plus 1 minus e, I've got to do the absolute value of that function, which no big deal because I'm just putting it in my calculator anyway, which I can do absolute value in my calculator. I go math, 9 for my integral. I'm going -2 to 2. And then before I type in my function, I'm going to hit, there's a few different places you can get it. If you have the TI-84, alpha and these buttons at the top, your window, your y equals, give you shortcuts. So alpha, and if I hit the window button, the very first option is my absolute value, okay? Or you can hit math and you go over to where? Number. NUM, and it's the first option there. Either way, you get to the same place. And now I'm just going to put in the same function. I'm going to put second e raised to the x plus 1, and then I'm going to minus e dx. So my answer here is 15.0168, which means on the AP test, I could put 15.016 feet or 15.017 feet. Either way, I'm going to get the right answer. But if I put 15.015, it's going to mark it wrong. So be careful of using that on the AP test. As long as you round correctly or trunk the problem, you'll be okay. All right, moving on. Let's do a couple more. I'm going to try and keep this video a little bit shorter than what we did last time. Mostly just, I don't want you to have to sit through a 40-minute video. So this one's probably going to be on the shorter side. In fact, part of this we're going to do in class. We're going to do another AP test problem, and that's one that we'll do, most of it we'll do in class at least. So back to this one though. Given the acceleration of a particle in feet per second, find the displacement and distance. So same thing, I'm looking for both the displacement and the distance traveled. Again, this is one that I'm probably not going to have to do by hand, but let's at least set it up and then we'll let the calculator do the work. So if I'm looking for displacement, I'm just taking the integral from 0 to pi halves of my original function, 3 cosine t dt. Okay. Actually, you know what? It's giving us an initial starting point. So if I was okay, I'm looking at this problem, I'm going, wait a minute. I don't need all that information, but I do, because guess what? This is the acceleration. Read ahead, Mr. Reed, come on. So it doesn't give me my velocity, it gives me the acceleration. So before I need my velocity function. So I've got to work backwards to get velocity. All right, so if a of t equals 3 cosine t, I'm going to take the integral of both sides. Okay, so what that means is this becomes v of t, this becomes my velocity. On this side, the integral of 3 cosine t, I've got to take, that 3 is going to stay out in front, right? And then cosine becomes sine of t. I'm going backwards, not forward, so my cosine becomes sine of t, and then I've got to add c to that. And that's why it gave me initial conditions, because I need the c so that I can get my velocity function. So it tells me when t is 0, so if I put 3 sine of 0 plus c, then my v of t is going to be negative 4. Now, my sine at 0 is just 0, so that means negative 4 is just going to equal c. So my velocity function is 3 sine of t plus c. Now I can take the integral. So if I take the integral from 0 to pi halves of 3 sine of t plus c dt, not plus c. Why am I putting a c again? We know what c is, guys. Oh, it's been a long morning, right? My c is minus 4. So 3 sine of t minus 4 dt. All right, see, I told you it would happen. Let's go ahead and put that in our calculator because we can on this part of the test. So I'm going to do, we've got to go math. We're going to go integral. And I'm going from 0 up to pi halves, so pi halves. And my function is 3 sine of, and again, I'm going to use x. I know the problem says t, but my calculator doesn't know the difference. So I'm going to go ahead and use x, but in my head, I'm going to remember it's not an x, it's a t. I hit enter, and I get negative 3.283185. So this is approximately negative 3.283. Is that what we said? And our units are feet, because again, it gave us velocity is feet per second. So on the AP test, you would have gotten a point for this. You would have gotten a point for putting feet in, and I am willing to bet that you would have got a point for coming up with the velocity function. So if this was an AP question, that right there would probably be worth 3 points. Now it also wants me to find the distance, and the distance is the same function. I'm still going from 0 to pi halves, but this time I take the absolute value of 3 sine of t minus 4 dt. So again, I'm going to put this in my calculator. It's not something I need to do by hand or in my head or any other way. So I'm going to go math, 9. We're going from 0 to pi halves. And this time I've got to put my absolute value of 3 sine of x or t or whatever the heck else you want. And then I'm minusing 4. So this one I get 3.2831. So again, I get approximately 3.283. But notice this time it's positive because it's my distance traveled. So of course it's positive. But here's something interesting. My distance traveled and my displacement are the same. My displacement tells me that I went in the negative. Overall, I'm negative from where I started. So let's say I started here. My displacement tells me that now I'm to the left. And because my distance traveled is the same as displacement, that means I only went straight to the left. This isn't a function where I went to the right and then turned around and came back. I only went straight to the left. Okay, AP question. I think this is one that we want to do in class, okay? So we're going to do, because Part C, if you want to try it right now at home, Part C is what relates to what we just learned today. So you're just going to set up an integral, use your calculator on it. Now, I know this says question 3, and usually question 3, you can't use a calculator. But back in 2002, on the free response test, there were 3 calculator questions and 3 no calculator questions. So even though this is question number 3, because it's an old question number 3, you can use your calculator on this one. So if you want to try this problem yourself, it wouldn't hurt to try the whole thing. Go ahead and try A, B, C, and D. Part C is what applies to what we did today. The rest apply to old stuff that you've already learned. But go ahead and give at least Part C a try. But this is one that we're going to go over in class. We're going to do this problem together. Whatever you don't get done, we'll kind of work through it together as a group in class.